Okay, so we're going to compress vertically the y value by 1/2. So to do this as a transformation, we're going to do it like this. 9x squared minus 4. Now there's two ways we can do it. We can do this as y over 1/2 like this, squared, plus 36 equals 0. Okay, so that's one way we do it. I'm actually going to do it slightly different. So we know we're compressing vertically, we're going to do the opposite. We're going to times by 2. So when we expand this out, we end up with 9x squared minus, so this is going to be 16y squared plus 36 equals 0. Okay, so what we've done is expanded vertically by, or compressed by 1/2. This coefficient gets bigger as we compress along the y-axis. Okay, now we'll see in the next one, it actually gets bigger relative to the other, to the a value, because that ratio of a squared to c squared actually is how we determine our radius. So if we're compressing horizontally by 1/4, okay, so we're gonna do this. 9 compressing is gonna be timesing. Okay, we're gonna do the opposite. Minus 4y squared plus 36. So notice that this it doesn't change the coefficient. It's not going to change the coefficient c. So this one, it changes the coefficient c from -4 to -16. This one doesn't actually change the coefficient. So it's going to be 16 times 4, which is 144 x squared minus 4y squared. So it doesn't change the coefficient of c, but the ratio of these coefficients is different. So as this gets bigger, it's going to be compressing along the x-axis. It's going to be getting smaller along the x. Okay, so what about this one? We're going to do a translation, and the translations won't affect the a and c values, but they should affect the d, e, and f values. So let's take a look. So we're going to translate a 3 up, 4 left. So it's going to be x plus 4 squared plus y minus 3 squared. So left 4 minus minus, up is plus, so minus plus, equals 16. So how does this affect the d, e, and f? Well, d, e, and f initially were equal to 0. So f is equal to -16. So will those values change as I do my translation? So let's see. So I'm going to end up with x squared plus 8x plus 16 plus y squared minus 6y plus 9 equals, I'm going to move the 16 over to the side, so minus 16 equals 0. Some of these like terms cancel out. So I end up with 1x squared plus 1y squared. So notice that the coefficients on a and c don't change. However, the d, e, and f do change. So the d value plus 8x. The e value is minus 6y. And the f changes from -16 to plus 9. Okay, equals 0. So the change in d is going to be from d equals 0 to d equals positive 8. The change in e was e equals 0 to e equals -6. And the change in f was f equals -16 to f equals positive 9. Now it's kind of hard to see how these changes occur, but we can see that the horizontal change is kind of reflected the same way the quadratic was. 4 left, doubled the middle term, 3 left, 3 up, doubled the middle term. And they have a similar relationship for the quadratic, that Vieta's formula. Okay, that's half the middle change is going to give us that. Okay. Okay. So how do these, it's really hard to, the A and C are very straightforward. We know how they change. The E and D and E change has something to do with the horizontal shift here and the vertical shift here. Okay, so that's E value. Vertical shift here. So those changes have something to do with horizontal shift and vertical shift. This one has kind of, it's just a mishmash. So what's happening there? So what's happening as we change the values, F values from negative 10 to 10. So we're going to start with this graph, and then we're going to see what happens. We're going to just go to our graphing tool and do that. So basically, we have our hyperbola. Okay, it's a rectangular hyperbola. So what's going to happen to this rectangular hyperbola as we change the F value?